Hello and welcome to the Data Engineering Podcast, the show about modern data management. What advice do you wish you had received early in your career of data engineering? If you hand a book to a new data engineer, what wisdom would you add to it? I'm working with O'Reilly Media on a project to collect the 97 things that every data engineer should know, and I need your help. Go to dataengineeringpodcast.com/97things to add your voice and share your hard-earned expertise. When you're ready to build your next pipeline or want to test out the project you hear about on the show, you'll need somewhere to deploy it, so check out our friends at Linode. With 200 gigabit private networking, scalable shared block storage, a 40 gigabit public network, fast object storage, and a brand new managed Kubernetes platform, you get everything you need to run a fast, reliable, and bulletproof data platform. And for your machine learning workloads, they've got dedicated CPU and GPU instances. Go to dataengineeringpodcast.com/Linode, that's Linode today to get a $20 credit and launch a new server in under a minute. And don't forget to thank them for their continued support of this show. You listen to this show because you love working with data and want to keep your skills up to date. Machine learning is finding its way into every aspect of the data landscape. And Springboard has partnered with us to help you take the next step in your career by offering a scholarship to their Machine Learning Engineering Career Track program. In this online, project-based course, every student is paired with a machine learning expert who provides unlimited one-to-one mentorship support throughout the program via video conferences. You'll build up your portfolio of machine learning projects and gain hands-on experience in writing machine learning algorithms, deploying models into production, and managing the lifecycle of a deep learning prototype. Springboard offers a job guarantee, meaning that you don't have to pay for the program until you get a job in the space. The Data Engineering Podcast is exclusively offering listeners 20 scholarships of $500 to eligible applicants. It only takes 10 minutes and there's no obligation. Go to dataengineeringpodcast.com/springboard today and apply. Make sure to use the code AI Springboard when you enroll. Your host is Tobias Macy, and today I'm interviewing Ori Rafael and Yoni about building a data lake for the DBA at Upsolver. So, Ori, can you start by introducing yourself?
Sure. So I'm the CEO, one of the co-founders of Upsolver, coming from a DBA, big data integration background.
And Yoni, how about you?
Hey, I'm Yoni. I'm the CTO and the other co-founder of Upsolver. Most of my experience before Upsolver is around data science, big data preparation, streaming data, all sorts of stuff like that. And then, of course, in Upsolver, building high-scale data lake platforms.
And Ori, how did you first get involved in the area of data management?
I was working on a data lake with Yoni. We were trying to solve an advertising optimization problem over a data lake. And we found ourselves spending a lot of time, a lot of data engineering time, just so we'll be able to query and work with the data. So I think I was a good DBA, but I didn't really have the ability to go and work with the data lake directly. So that's when we started working with data management, and that's when we kind of talked about the idea.
And Yoni, how about you? How did you first get involved in data management?
So I think for me, it's always been something that has been top of mind. So from my first job was in the IDF, and I was a DBA. Then after that, as a data scientist and a researcher and applications developer, finally CTO there. And throughout everything, everything was data there. Everything is small volumes from today's perspective, but from then it was large volumes of streaming data, a lot of kind of tricky decisions on how to manage it and where to put it. So it's always been something that was super interesting for me. And then I think that in Upsolver, I think we very easily gravitated towards that of taking on this hard problem of how should this data actually be managed? What are the best practices? And do people really need to worry about it at all? Or should it just be done Is there a right way to do it?
So, Yoni, you've actually been on the show about almost 2 years ago now in November of 2018 when we talked a bit about what you were building at Upsolver there. And so it's this platform for managing data lakes in the cloud. And before we get too far along in the conversation, can you each give your definition of how you consider what a data lake is and what it's comprised of?
Sure. So I think that the easiest way to think of a data lake is that it's a decoupled database. So I'm taking the storage part, the metadata part, the compute part, and kind of starting to manage each one separately, which gives me a lot of advantages when it comes to elasticity and cost management and scaling. And on the other side, it creates a lot of complexity. think that would be my definition.
Yeah, I think for me, like in the end, a data lake is a cost thing. It's, data as data volumes grow, databases are great. They're really, really good at what they do. But as data volumes grow, it just becomes too expensive. And the cost also means how much data you can deal with. So if I have a database that costs me $1,000 per terabyte, then at 50 terabytes per month, at 50 terabytes, I'm thinking to myself, well, maybe I don't want to store this data anymore. And then along comes the data lake, and it really opens up your capability to deal with a lot more data just because it's so cheap. So it's really like, I mean, in the end, the bottom line really makes the whole difference. So I'd say that for me, like a data lake is the natural progression towards larger and larger data sets. And I think it's very important to think about that as, the data lake shouldn't be a compromise. Like I think maybe today for a lot of people it is a compromise that they would rather have the data in a database, but like it should be as powerful and as useful as a database. So then from my perspective, that would just, since I see it as that's the case, it would just be the natural progression that things just go there.
And some of the initial ways that the data lake started to manifest was with the Hadoop ecosystem and the MapReduce project and the HDFS file system for being able to spread your data across multiple machines. And nowadays, a lot of people are using object storage for the actual storage mechanism. And even in the past 2 years, there's been a lot of movement in the availability of different technologies for working with data lakes and different managed platforms such as yours for being able to build out a data lake with a single layer. And I'm wondering how the overall landscape of data lake technologies and the overall adoption of data lakes as a solution for businesses has changed since the last time that we spoke.
I mean, I can jump in and say that, from my perspective, I think the tools have become a lot more powerful. So if 2 years ago, there were a few compromises that you really had to make, because in the end, if you're talking about like a data lake, so it's not an SSD. You have an access latency. Of course, there's all the eventual consistency issues of your storage and things like that. And I think that over the past 2 years, these issues have pretty much been resolved. So like today from object storage, you get performance that's equivalent to SSDs. And I mean, the cost hasn't gone down much in that time. But just the fact that the performance is so much better today means that I think that pretty much any use case you can think of, you could solve using a data lake, given the correct data modeling.
Maybe the other thing, Tobias, is the popularity. So today I feel like 2 years ago I was still explaining data lakes in many cases, and today like everyone has a data lake agenda. And like if you look at like the top companies in the market today, so you look at like the Spark adoption, like everyone are doing Spark, like I think much more comparing to 2 years ago. And if you look at the big data warehouses, so they're trying to start calling themselves, we are a data warehouse, we are a data lake, or we are a data platform. And they try to add capabilities to query both their traditional model, but also query the data lake directly. And I think you see it across all the big vendors. So you have Redshift with Redshift Spectrum, giving them the data lake capabilities, and you have the launch of Azure Synapse Analytics with serverless queries over blob storage, and BigQuery has BigQuery external tables in beta. So Snowflake calling themselves the data platform today and not the data warehouse, cloud data warehouse like they did in the past. So I think that's a big change when everyone kind of want to succeed with the data lake use cases with different types of solutions.
And how do the cloud data warehouses such as Snowflake or BigQuery differ from the full-fledged data lake in terms of what they're available to offer and maybe some of the cost issues or performance capabilities compared to using the native data lake technologies, whether that's things like Presto and Spark or a managed platform?
So, I'd say that there are two major advantages that you have to a data lake. One is the cost. And I think that both BigQuery and Snowflake are kind of addressing the cost. I mean, of course, there's the cost of the platform itself, but like beyond that, there's still like the cost per storage is going to be similar to a data lake. So I think they're really like, and by the way, you see that across a lot of vendors. I mean, also Kafka now have or I'm not sure if it's out yet or they're releasing it as we speak, but they have like the S3 extension to the Kafka stream, or you have like like Redshift using Redshift Spectrum. So they're all kind of adding these extensions to the data lake and enjoying the cost. But specifically when you talk about Snowflake and BigQuery, the data is sitting inside these systems. So once it goes in, it doesn't come out. And I think that really breaks the second big advantage of the data lake, is that you can put it before other systems. So it goes in the middle of your architecture. All your data comes in, it goes into the data lake, and then you can do whatever you want with it and send it to whoever wants to consume it. And with BigQuery and Snowflake, you really pretty much need to consume it within BigQuery and Snowflake. And I think that really limits the flexibility of what you can do. And also, like, there are a lot of use cases. Like, I mean, if you want to use a key value store, you can't really, like, there's no way to pull the data out of Snowflake to put it into a key value store, really, that's going to be effective or like, yeah, exactly.
I think as a DBA, like talking old age DBA, we solved everything with Oracle because our data was in Oracle. So today it's called BigQuery or Snowflake, but if their data is there and it's in a proprietary format, I'm going to go to great length to solve the problem there and not to replicate the data to additional database. And Data Lake gives me that ubiquitous access option that I don't have with databases that come with a proprietary format.
And so in that same time span of roughly the past 2 years, in addition to the changes in data lake technologies and its overall adoption, what are the ways that the Upsolver platform has changed or evolved since we spoke? And how has the evolution of those underlying technologies impacted your strategy for implementation and the features that you decide to include?
So I'd say that I mean, last time we spoke, that was in 2018. That was like our first year of general availability. So, I mean, of course, the platform has changed a lot as far as just maturity and kind of scale, how much data we can deal with, how much data we are dealing with. So like today we have customers that are putting 2 gigabytes per second to the system, which was like a far cry from where we were then. And I'm sure it can scale much, much beyond that. But so far that's the biggest. But then I think that the main difference between the platform then and the platform today is that today we have a SQL as a definition language on top of the UI-based architecture. So it used to be just UI. It used to be that you could define everything using a user interface, and you had a very broad set of capabilities. But today you have full SQL on top of your data. And I really think that that's a game changer, because in the end, I mean, UI is very nice. It democratizes in a way that even SQL can't necessarily, because not everyone knows SQL. But in the end, SQL is the language of data. I mean, even if, like, no matter what ETL process I'm doing, in the end, I'm most likely going to be querying the result using SQL. So it's really, I think, a huge difference that you have one language for the entire pipeline. And then the second question, I mean, about the underlying technologies. So the fact that S3, I mean, I'm not sure how much people are aware of this, because S3 was always really powerful, and I'm not sure how many people are actually pushing the limits of S3. But it used to be a few years ago, they had like a best practices. You want to have these prefixes to your buckets that are hashes, which completely didn't fit with anything else that S3 does, but it was kind of like a performance optimization they were telling you to do. And about a year and a half ago, they released a new article saying, well, actually, you don't need to do that anymore. And by the way, remember that we told you that it's good for 100 requests per second. So now it's good for 5,500 requests per second. And you can scale it out between different prefixes in the bucket and between buckets. So you can multiply that by 10 if you want. So I think the difference between 100 requests per second and 5,500 or 55,000 requests per second to your S3, your blob storage layer, is basically means that you can do anything. Like, you really don't need anything aside from this super cheap storage, which wasn't necessarily the case 2 years ago. So I think that's a very big difference.
And so in terms of the adoption and implementation of data lakes, what are some of the common challenges that accompany that, whether they're using a managed platform or doing some self-built system using a lot of open source technologies? What are some of the difficulties or complexities that arise regardless of the actual technologies that you're building on top of?
I think, if I'm paraphrasing, the fact that I'm using a data lake, what gotchas are there? How is that making my life miserable? So I think that in general, in a data lake, you really need to worry, or at least traditionally, you would really need to worry about the low-level stuff. It's not like, in a database, sure, you have a DBA and you have to build your indices and things like that. But I mean, in the end, you're not worrying about how the database is storing the files or if there's like replication going on or what's happening behind the scenes to make sure that it's load balancing or stuff like that. All that stuff is handled for you by the database itself. With a data lake, it's even worse than that. Like you don't only need to worry about the load balancing and the like where you're going to store it and how you're going to store it. It's also, in the end, you're using this very, like, I mean, I was just saying how powerful it is, but it's actually very weak in the sense that you don't have a lot of capabilities of discovering data. I mean, you pretty much need to know where it is. So you have this file system, and you have to figure out your folder structure, you have to figure out your file formats, you have to figure out your compression, like all the stuff that a database would normally do for you, you need to do on your own. So like all these, triggering, so process management and orchestration and if you want state, where to keep the state, and like in the end, it's a mess. So it comes out that like 90% of the time you're working on kind of like making sure that your data lake is performing as a database should, or performing as the storage system of a good system would be, and kind of just like putting it in place and preparing that and massaging it, making sure it's good. And then 5% of your time is actually doing stuff with the data, is consuming it. Like often it's going to be different people doing the two. So then the people who are consuming the data lake are just going to be waiting for people to implement stuff for them. But yeah, I think that's, I mean, on-prem it's even worse, because then you even have to manage the storage itself. I mean, Hadoop isn't HDFS isn't the easiest thing in the world to manage. But even in the lake, and you have S3, and that's super great, but you still need to do a lot of work to make sure that everything works as it should. I mean, it doesn't really add up in the end. I mean, you hear that a lot about data swamps, that you wrote data into your lake, and then it became a swamp because you can't access it. You lost the data basically. And it's even worse because you're paying for it and you can't even really delete it because you don't know where it is. So I think that would be the common challenge, is that you actually have to build the data lake and you're not just consuming a kind of pre-built product, which is a data lake.
So Upsolver, I know, aims to solve a lot of those challenges of ensuring that there is some appropriate modeling going on and that the data as it's being written into the lake is optimized for access and scale. And you mentioned, too, that with a database, you generally don't need to worry too much about what's going on under the covers because it handles a lot of it for you. But for people who are using a data lake, particularly if they're using something like Upsolver, what are some of those underlying realities of the data systems that power the lake and power your platform that still need to be understood by the operators to ensure that they don't accidentally shoot themselves in the foot?
In Upsolver, pretty much they only think about how they're going to do transformation of data. So they're pretty much mapping their raw data into tables. So we're not giving them any control over orchestration or how exactly data is. We give some configuration control, but the idea is that the approach is don't let the users do what they shouldn't do. Don't let them trip. So you're kind of asking where they could still trip. And I think it's more like the concept of how you're going to eventually organize the data. So I'm, as a DBA, I'm always used to creating relational models. So I'm creating a relational model, and then the user answer their questions as views on top of that model. But if you go to a data lake, you can't create a relational model because data lake is not indexed. All of those joins will not work well. So you should pretty much take your raw data and map it directly into tables that are not necessarily relational. And I'll try to maybe illustrate that with an example. So let's say I'm working on an advertising problem. I have a table of impression and a table of clicks. So I could just go and create a table for each one and then try to join them, and it will just not work. But the way I would approach it in a data lake, I would create a table that includes both the impression and clicks and let the user query that. Although it would consume more storage is cheap. It will be much more beneficial from a query perspective.
Yeah, I think when I think about databases in the end, I mean, there are two things in a database that I need to worry about. One is the data model. So making it making it consistent with itself and making it correct and making it useful. And then the second is that I don't run out of space. That's pretty much the two things I care about. I can't run out of space, and I have to make sure that the data is well modeled. I think in a data lake, I mean, you don't have that space constraint. You don't need to worry about running out of space. So then you can solve problems in a much easier way, I would say. And yeah, like the denormalization is one of those things. I'd say a main thing that like in the data lake, I mean, you don't need to worry about that. I mean, it's actually simpler. It's closer to how people actually think about stuff rather than a traditional database.
And with this SQL layer that you introduced, you mentioned that there was always a visual workflow for being able to work with the information in the lake, but how does the introduction of that SQL capability change the accessibility and the overall staffing options for people to manage the data lake?
It's eventually 20 times more users. So if you we tried to do this research, we went to LinkedIn looking like how many people know SQL, like how many people know data engineering or Hadoop or those kind of technologies. You see that like the number of data engineers in the world is like 2% to 5% of all data practitioners. And like also take a look at like the growth in number of data lakes. So if I would look at on-prem Hadoop, like combine all the customers from Cloudera and Mapr and Hortonworks together, I think I'll reach to less than 10,000 like paying customers for like pay distribution of Hadoop. And I'm looking at Amazon S3 and there are over 1 million customers. So you have like an exponential growth in data lake. You definitely don't have an exponential growth in number of data engineers. So I think the biggest, most important thing is Upsolver is the ability to go to 20 times more users that are getting direct access to the lake and don't need to drive the entire process through IT or through big data engineering.
And I think like when you're talking about SQL, so it's very easy. A lot of other systems, like I don't want to badmouth anyone, but a lot of systems would say that okay, we support SQL, and like in reality they kind of support okay, like you take your select from, where, and like be thankful for the five built-in functions that we give you. And I mean, okay, sure, that kind of is supporting SQL. Like it means that you're still defining your transformations in SQL, but it's not really that useful. In the end, it's very much limiting your capabilities in order to fit into the language. Or rather, like maybe the capabilities were limited to begin with, and then the language is just reflecting that. I think there's a big challenge in making sure that you're actually like both giving fully fledged SQL, so actually having all the capabilities that someone would expect from SQL, which is not trivial when you're talking about streaming data, especially, and also not on top of the data lake, and then also making sure that people understand that given that they're defining their ETLs in SQL, they're not losing any capabilities. It's not like if I were to write things in code, SQL would be like I would be able to do other stuff or do better stuff or do what I want, and I can't do it in SQL. Like you kind of need to re-educate people. And I mean, in databases, they were already convinced. People switched there because they understood that they could do all their data stuff in SQL. You kind of need to convince now that actually you don't need the code in Spark. You can do it in SQL, and it will actually do everything you want.
And so in terms of the actual ways that you have implemented SQL, I know that you're using the ANSI standard, but what are some of the useful extensions that you have incorporated that are relevant to the data lake context that simplify the work of your users?
So I'd say there are 3 very powerful extensions. The first one I kind of wish was part of ANSI to begin with. So SQL is super nice for data modeling and everything, but it's very hard to build functions on top of one another. So for example, I want to do A pipe B, like I want to just concatenate 2 strings, that's fine. And then let's say I want to concatenate 2 strings and then do something else on top of that. So you can also do that, but then you can't reuse it anywhere else in your statement. So often you're going to have like in your select statement, you have a function, then you have the exact same function in your group by or in your where clause, just because there isn't any composability there. So one extension that we added is basically you can think of it as a procedural set statement. So set field name equals whatever transformation. And that like single small addition to SQL allows you to define complex transformations and then consume them in additional like down the stream in additional parts of your SQL statement. And I think that SQL's answer to that is using subqueries. So you define a bunch of transformations in your innermost query and then use another subquery to define additional transformations on top of that. And like it becomes horrendous. It's very hard to read that kind of statement. So I think using the set statements really simplifies kind of, and especially like often in SQL for ETL specifically, you'd have like 10 or 15 different data transformations. It would really become a nightmare without that. So I think that's one very, very big difference as far as the capabilities of the language. A second thing is that, so SQL is traditionally made for for relational databases which are flat. Like your tables are flat, and then eventually they added JSON support and they added like nested column support and stuff like that. But it's very clunky and nobody knows about it. Like nobody knows actually how to interact with nested data using SQL. So we added a few language extensions around dealing with nested data within the original structure. So, I mean, conceptually, and this is maybe it's a bit hard without drawing it, but like conceptually, you have, let's say you have a purchase, which is a JSON. And this is how raw data comes in. Like 90% of the raw data we see in the world is JSONs. So you have your purchase, which is the root of the object. And then you have an array of items. And each item might have, let's say, a quantity and a price per item or something like that. And now I want to reason about these things. And usually what you're going to do is all your transformations are either happening at the item level or they're happening at the purchase level. So I might want to say, multiply the quantity of the item by the price of the item. And then obviously I want to multiply within the same item. I want to scope that calculation to each individual item. I don't want to like take, I don't know, all of the, as would by the way happen in native SQL, I don't want to take all of the prices and do a Cartesian product with all of the quantities and then multiply everything together and get an array of n squared size. Like that doesn't make any sense. So we have a language extension, which is very subtle, which simply allows you to access fields within arrays directly. But when you do that in Upsolver, it makes sure that all the transformations that you do are scoped correctly based on kind of like if I'm multiplying two values and they're scoped together in a field, so it'll multiply within that field and not out of it. And that really makes a very big difference as far as the ability to, I mean, because again, like people working with SQL, obviously there are the SQL superstars and there are the people who kind of like, it's SQL as a second language. So you don't want to force the people with SQL as a second language to just not ever deal with their nested data. Yeah, and I think the UI also helps there because it kind of exposes the syntax in a friendly way. When you add it from the UI, you can see what the SQL generated by it looks like. And then the third thing, and this is getting to be a pretty long answer, but the third thing I would say is that SQL generally deals with static data. So you have kind of a table, the table is finished. I mean, it's not always in SQL databases, new data is coming in all the time. But in essence, when you run a query, there isn't really a built-in temporal aspect. Whereas when you're dealing with data lakes and streaming data, there has to be a built-in streaming aspect because I have to deal with everything incrementally. So when an event arrives, when I'm joining, I need to reason about when did that event arrive and what portion of the lake am I joining into. So we added a few language extensions around being able to bring in, for example, the latest data or waiting for a few minutes in order for the data from the other stream to catch up or things like that. So there are a few additional keywords that we added, which allow you to kind of seamlessly deal with streaming data without needing to build huge subselects that do those constructs.
And yeah, there's definitely been a trend that I've been seeing in the overall data space of this move towards streaming SQL. So a lot of that is implemented on top of things like Kafka streams with KSQLDB, or there's the Aventador platform for handling streaming data using SQL. Yeah, there's also the Materialize platform. There's a lot of open source implementations. And so it seems like there's this sort of implementation specification of how streaming SQL works, at least conceptually. I'm sure that there are variants in terms of the specifics of the syntax. And I'm wondering what your thoughts are on the overall space of streaming SQL and what you see as being the future of that in terms of incorporating it into the broader specification of SQL and its necessity given the current ways the data is being used.
Yeah, so I mean, first of all, you have to keep in mind that the SQL specification is, like, how do I put this nicely? It's maybe a bit of a legacy thing. I mean, I know it's maintained. You have SQL 2016, and you have a lot of versions of SQL, and they come out with a lot of new stuff. But really, people are stuck in 1999. It's not like, common table expressions kind of became standard. People know about them more or less. But a lot of the new features that you have in the SQL standard, they're actually not very standard. Like none of the databases actually support them. And like even the old features, you have a lot of stuff in there that is completely irrelevant now. Like all sorts of like Fortran support is part of the standard. It's not that relevant. So I'm not sure how much it's important, because anyways, nobody up until 10 years ago, when you weren't talking about streaming SQL, just SQL, still there wasn't actually a standard. The standardization was very was only skin deep. So I think that today it's kind of the same. Everyone has their own flavor. They all have their own extensions and their own additional kind of keywords and how they reason about things. I'm not sure that's the end of the world, as long as people kind of stick to the basics and make sure that at least when someone writes a SQL statement that's kind of using the common base of knowledge of people writing in SQL, that it's going to do what they expect and not something weird. And then if you add a keyword here and there, I think it's less important that would actually be standardized, just because it never was. So and then even if you add it to the standard, let's say if KSQL really does really well, or if Upsolver does really well, and all these changes I just said are added into the SQL standard, is KSQL going to change? Probably not. I don't think they care that much. So yeah, I'd say the standardization is less important, but keeping things as concise as possible and as close to the base as possible, I would say, is maybe the most important thing. And then when talking about streaming SQL, so definitely this is a huge thing. It's a huge departure because it's not traditionally part of the language. And that's also it's a very big conceptual shift for data consumers. And I think maybe that's one of the challenges that we see is that people need to start reasoning about streaming data where they're used to thinking about static data sets. That's a big difference between Upsolver and Spark, for example. Spark it talks static, and then you can do streaming on top if you want, but the language is static. And whereas in Upsolver, the language is streaming, but then you need to educate around that. People need to realize that, today data is streaming. That is what it is, kind of.
There's also the difference in terms of perspective of the initial broadly accepted view of the Lambda architecture, where you have this separation of batch versus streaming, and you process streaming in real time as it comes in, but then you periodically go and backfill using your batch data to make sure that you have a high level of accuracy. And then there's been this proposed Kappa architecture, which is more focused around streaming and being able to maintain aggregates based on that streaming data. And I'm wondering what your thoughts are on the overall ideas of Lambda versus Kappa, or some of the different ways that you can architect to be able to account for streaming data while still being able to get some more detailed analysis based on the data that has actually landed in your lake, rather than trying to maintain these windowing functions where you have an imperfect view of the entire history of your information.
Yeah, so I'd say that first of all, the problem with Lambda architecture is that you need to write stuff twice. You really don't want to be writing stuff twice. And especially the fact that, Lambda came out of the world of batch when they wanted to add a streaming layer. So you have okay, I already have my batch. Now I'll add an additional streaming layer and figure that out in a separate language or something. And so I have my Lambda architecture. And then I think Kappa is kind of maybe it's a bit naive, but conceptually it's saying, well, let's discard the past and say all the data is streaming anyways, kind of like what I've been saying now. And so actually, why do you even need the batch layer? Maybe just use the streaming layer and it'll do the batch and everything will be fine. And of course you have performance issues and you have to make sure you're not losing capabilities here, but definitely you have to have one language. You can't have two definitions of your same ETL. It has to be defined once, and then your infrastructure needs to convert it to either the streaming layer, if you have such a separation, into the streaming layer and the batch layer. And from Upsolver's perspective, what we did is we're really trying to do we're a data lake platform. So of course we can deal with huge amounts of historical data and batch data and all that, but we treat it as streaming data. So in a sense, I'd say that's similar to Kappa architecture in the sense that we only have one way of dealing with data, which is streaming. But we do that in such a way that you can deal with a huge infinite amount of data. So I'd say slightly different from, let's say, how Flink, the main proponents of Kappa would be, I would say, Flink. And the way they do it is kind of you have a stream of data and you can just just run that stream from the beginning fast and maybe separate the stream into a lot of different streams. But that kind of requires a lot of preparation in advance. In Upsolver, we build the data lake in such a way that you can just run your Kappa on top of the entire data lake very quickly by splitting it up into time chunks and stuff like that, but you're still streaming over everything.
Tobias, one thing that you mentioned is the sliding time window and the limitation there. And I think that's one big limitation that Upsolver addressed. So the way the streaming systems were built is that you can only address data and work with data that you can currently fit in memory in that time window. So we built an indexing system that goes with your stream. So when you want to combine your real-time data, you can combine it with all your historical data and not just the data that you can fit in the window. Our objective here, do everything with a stream and implement Kappa and not do Lambda.
And one other thing that I want to call out from your earlier answer, Yoni, is the handling of nested data, because as you said, that is one of the consistent challenges, particularly in data lake systems, is you don't want to have to pre-process the information a lot before it comes into your lake. And so you do often end up with these nested JSON structures or other formats that have nested fields, and being able to access those in an intelligent and natural way is something that's a shortcoming of a lot of the platforms that I've tried to use at various times. And so in the data warehouse approach, you would generally handle that flattening of the nested structures as part of your transformation before loading it into the database. So recognizing that being able to handle those fields is definitely a benefit to people who are trying to work with their data without having to do a lot of upfront work ahead of time and potentially lose information or lose context by flattening things without necessarily introducing the appropriate sort of information as to where those flattened fields originally existed.
I mean, definitely the data lake needs to represent the original data, the data that was generated. I mean, if you're doing data transformations before dumping it into the data lake, you're doing it wrong, kind of. Because I probably shouldn't make such like strong statements, but any data transformation you do, and like you say, like you lose the link, and then it's actually gone forever. So you really want to make sure that your data lake is at least your single source of truth.
And so going back to the SQL implementation, I'm wondering if you can talk a bit about how it's implemented in your overall architecture and just some of the ways that the implementation of your system has changed since the last time we spoke.
So, I mean, the way we did SQL in the end is you can think of it as a from the bottom up rather than a top down approach. So it's not like we said, well, okay, we want SQL, so let's just add SQL and see what works. It was more like we had in the back of our minds that SQL is important, but we didn't want to get to a point where we have a partial SQL language. Like we didn't want to get to a point where, okay, I support SQL, but no joins, or SQL and no group bys, or like things like that. So from our perspective, what we did is it was kind of like, okay, so first of all, do we actually have a full support for data transformations that you'd expect in SQL? And then we had that. And then it was like, okay, and how about dealing with filtering? Okay, that's pretty easy. We had that. How about doing joins? So that one's pretty hard. And I think that implementing SQL made us, so I mean, the underlying capabilities were actually already there as far as joining. So the way a join works in Upsolver is that you build an index of the right-hand side. And that index is sitting in S3, so it's still in the data lake, but it's a conceptual key value store equivalent to what an index would be in a database. And then when you do a lookup from it, so when you do the join, that join is going to perform very fast. So that general capability was already there. We already had, at the time we called them indexes, now they're called lookup tables. But we already had that capability, but the adding SQL really forced us to understand exactly what's necessary as far as the definition and boil it down to really the basics. So I can say, select from stream left join this lookup table on key, and that's it. And then it'll work and it'll do exactly what people expect it to do. So I think it forced us to be a lot more concise about how you define these things. And then for group bys also. So, I mean, group by is actually a pretty interesting semantic on a data lake, because you kind of have, like in a database, when you run a group by, it runs on the entire query. So I have a database with 1 billion records, and I say group by key, get me the max value. And I'm not going to get the max value of the key from the last minute or something like that. I'm going to get a full SQL statement that just returns for that key the max value over everything. And I might have indices behind the scenes that help me resolve that. But in the end, the statement runs on all the data. And in a data lake, that's like, there isn't really that concept. You know, when I run a SQL in an ETL, it's like, okay, I'm always appending more data, but like, so what am I grouping by on? what time window is it? And then I'm going to have duplicate keys of the group by. That's kind of weird when I run my queries on top of the data lake. So I think that was for us the most challenging part, is adding this kind of like replacing functionality, so that, I mean, we support both because, of course, a lot of people are used to streaming data and they want this append functionality. So I say group by country, tell me the amount of users, and I want every minute to just get however many users there were in each country. I just want to add it, and I'll do an additional group by on my database, on my data lake layer. But the capability to say select country, comma, count distinct users from my stream, group by country. And what I actually want is that the result is going to be a table that has one row for each country, and it has the count distinct users in that country. And every minute I want it to update, so it'll have the new count distinct values. But that's all I want in the target. That's something that was conceptually super difficult to accomplish. And I think that was really like, to get SQL working, to get SQL out, from my perspective, we really needed to have that capability. So I think that was probably the biggest challenge from our perspective, is implementing kind of a real group by on top of a data lake.
And so in terms of when you're onboarding customers, particularly now that you have this SQL layer for being able to empower the DBA to be the owner of the data lake, what are some of the main concepts that you generally need to educate your customers on?
I think the main two things are the relational model that we touched briefly before, about not creating a relational model in the end, but actually create the views they want to query. And the other thing is think of your data as an event stream. So we said that the Upsolver approach is Kappa and not Lambda, and we want to do everything as stream processing. But the way you need to think about it is that you currently are looking at the context of an event, and you want to connect, enrich that event with historical data, and you're not joining static data sets. So everything has a time-based filter, a time-based way to think about it. Everything is additive processing and not standard batch. And a lot of people are kind of used to batch, and sometimes it takes some time until you do the leap forward to stream processing. And my experience has been with users that once they do it, they really can't go back, but it takes them time to do it.
And what are some of the features of your platform or capabilities or ways of using it that are either often overlooked or underutilized by your customers that you think they would benefit from using more frequently?
I think that since we met, and even since you interviewed Yoni, and even before that, we were very focused on analytics use cases. So the person in the end was querying the data. But Upsolver is a really good solution for doing machine learning, like streaming machine learning. And we have a few customers that are using it and very happy with it. But we haven't really spent a lot of time educating our users how is it right to build a data set from a stream in a way that you can actually productionize the models that you create afterwards. So I think that part is kind of overlooked, and it's something that we plan to change going forward.
With the streaming capabilities and being able to run machine learning models on your platform, what have you found to be the adoption or viability of being able to do something like reinforcement learning that requires that real-time feedback loop to be able to update the model and update its behavior in real time?
Yeah, exactly. That exactly hits the nail on the head. That's the kind of thing that's super easy to do with Upsolver, kind of ridiculously easy. Like, you don't even think about it and it just happens. Whereas people think of it as something that I might put it on my roadmap as a epic 5-year project to do something like that.
But let's be specific, Yoni. Let's be very, very specific. I think it's the fact is that you are doing everything with streaming, and the fact that you kind of protect the user from taking data data from the future, like create a leakage in their model, or the fact that we're doing everything in the stream means that you're not calculating your data set in one way and then doing the calculation of the features for serving in a different way. You have just one way to create the features. You don't need to go to search for unfindable bugs of what did I do differently between my batch process and my stream process. That's usually the main issue we saw, unless you see something else, Yoni.
You kind of have to, for real-time machine learning, you have to have kind of the Lambda architecture traditionally. It's really traditionally going to be, you have Spark for the offline, You have some code written in some language for the online. And really, these two code bases are never going to do exactly the same thing. And they often don't even have access to the same data at the same time. So because they're so different and because machine learning models are very, very sensitive to small changes to how the data looks, it's just like, I mean, these projects just don't work in the traditional sense. Like you kind of have to have the Kappa architecture. You have to have the single way of defining it and accessing the historical data. And it has to work the same on your offline data and on your online data. It has to work exactly the same. Otherwise, it's just not going to work. And yeah, I mean, that complexity just goes away because that's just how Upsolver does it.
In terms of your experience of building the Upsolver platform and democratizing it for the DBA to be able to handle the data lake and just growing the overall business and technical elements of the company, what are some of the most interesting or unexpected or challenging lessons that you've learned in the process?
Of giving it to the DBA?
Just overall of building Upsolver.
I think that you can probably asking both from a business and technological perspective, right?
Yes.
So I think for me, like we got when we only started, we were trying to always build the best product, always create the best engineering solution to every problem. And then you find out that the best solution is not necessarily a familiar solution. It's hard to keep educating users all the time. It creates friction in both the sales process and the implementation process. So we kind of changed our state of mind to looking at familiar all the time. I think the addition of SQL to the platform was after we have made many mistakes in which we didn't create an experience that was familiar enough for the users. And like we did a few POCs and like we felt that we provided a good user experience. And then this analyst comes and say, hey, I don't care about this UI that you have built. I know SQL. Give me SQL. That's what I understand. And once we added that, we found people starting to take, like the customers doing migration from data warehouse to data lake, they're actually taking their SQL from the data warehouse, copy paste them into Upsolver and start tweaking them. And that for me, it blew my mind. And that they're using it like this. I never imagined it. Once you gave them the familiar option, they started using the system in ways I didn't think about. And like you can take it to other features of the platform. Like why is Upsolver priced per compute? When you just got started, we try to price it by volume of data, but usually data processing solution or cloud is priced by compute. It's not that it's much easier to understand, but everyone already understands it. So I think that they also deployment, by the way we deploy today is we give you a cloud formation script because that's how people deploy software on AWS. So working with familiar, like putting an emphasis on familiar was maybe my biggest product takeaway from the last couple of years.
Yeah, I think also like, you have a ton of different features and it's very hard to concisely explain. I mean, there's so much complexity there and there's so much stuff going on, so many different capabilities. And then when you tell someone, well, it supports SQL, like that's really packing a lot of complexity into a very short statement because they already know what to expect.
And as you plan for the future of the business and look to the current trends in the industry for data lake technologies and usages of data lakes, what do you have planned for your roadmap?
So I'd say that definitely everything around portability. So today we're really AWS focused, but we don't want to be exclusively for AWS customers. We want like kind of anyone who has a data lake or wants a data lake to be able to do it if they're on-prem, if they're in Azure or wherever it is. So I think that's a big thing is just making sure that really everyone can have access. There's also data lakes have kind of a unique challenge, which is that, and I'm not sure how much it's affecting data lakes today, but I think this is definitely something going forward that's going to be more and more of an issue, is that you have GDPR compliance issues. So data lakes are very good for storing large amounts of data, but they're very unwieldy in the sense that you then, if you want to delete something, it can be almost impossible. And I think maybe today even many organizations are just kind of giving up and saying, well, okay, it's in the data lake, and maybe that's okay. I hope nobody sues me. And I think that's not going to fly too long forwards. And then so I think that building around, and we actually have some pretty interesting solutions to these problems as far as the data lake management. And I mean again, since Upsolver is a data lake management platform, it's like kind of trivial that we would be the ones that would enable these features. And I think that's going to be super important going forward. And again, they're features that exist today, but they're not wrapped in a way that like, okay, you have a GDPR compliance button, you can just click it and then delete a user like PII. So that I think that's something that we're definitely looking at focusing on. And then maybe the last thing I would say is just focusing on educating users. So like everything from documentation to tutorials to webinars to like workshops and training sessions, like everything you can think of, but just making them. And I think like, part of it is training on Upsolver, but part of it is a lot of the stuff we talked about today is like how to think about streaming data or think about data as streaming data. So that's another big focus of ours, is just to make sure that people can get it accessibly. Part of that is making sure the platform is as easy and familiar as possible. But part of it is making sure that there's a lot of information around it so that they can figure out what's going on.
All right. Are there any other aspects of the work that you've done on Upsolver or using SQL as the interface for data lakes or just overall data lake technologies and usage that we didn't discuss that you'd like to cover before we close out the show?
I think we touched most of the points. I mean, I'd want to say that I'm super super excited about what's going on now. Like, if a year or two ago, data lakes were on everyone's lips, and now today data lakes are in everyone's AWS account. So I mean, that's already a pretty huge thing. But I think that people don't understand the magnitude of the shift that's going to happen. Like, I don't think they realize. I mean, today still, I think databases probably account for more data, or maybe not. Maybe at this point, data lakes have more data than databases. But I mean, as data lakes grow exponentially and databases grow linearly, really all of the world's data is going to be in data lake. All of it. Like, it's going to be a rounding error or anything else. And so I think like having all of the different capabilities that you expect from the data lake, I mean, it has to happen. It's not like I'm also going to have all these other things. Like, storage has to be in the data lake because it's just so much more competitive from a cost perspective. So I think this is like a really exciting time to be talking about this stuff.
All right. Well, for anybody who wants to get in touch with either of you and follow along with the work that you're doing, I'll have you add your preferred contact information to the show notes. And as a final question, I would like to get each of your perspective on what you see as being the biggest gap in the tooling or technology that's available for data management today.
I think you're kind of playing it both extremes. Like, if you're talking about data management, you either have the databases option that give you the ease of use advantages, but kind of have all the pitfalls when it comes to scale and ability to use additional systems. So, and the data lake is still very, very complex. So Spark replaced Hadoop, but it's still complex as Hadoop. So I think that's kind of why Upsolver is very focused on that complexity as the main problem that we want to solve. I think if I would add to that, I would add the metadata management. So I think the fact that each database is kind of managing its own metadata is something that's going to change, since we have so many different databases and query engines, and concepts like Glue Data Catalog on AWS, Hive Metastore. So centralized metadata management, where you're also doing centralized security management, is something that's going to take a much bigger place going forward.
Yeah, and I'd say from my perspective, so I think that today data lakes are really only addressing a very small portion of the actual business use cases. So like often they're going to be an interim step or maybe like an end target for like long-term storage or something. But like today, the users that are getting a lot of value out of the data lake tend to be data analysts. And I mean, and of course, that's like a huge market, and that's like, our bread and butter today. But I think that like going forwards, more use cases. And that's something that I don't see today, is you don't see many people saying like, data lake for OLTP or data lake for like, data lake for stream processing, for that matter. Like, I think that these things should happen, because it's still, I mean, yeah, for stream processing, in a way, Kafka are saying that now when they're releasing their S3 extension. They're kind of saying, well, okay, yeah, actually, like, why do you need a giant Kafka cluster when 3 nodes can deal with 2 million events per second? But the reason it's big is because of all the historical data. So keep a tiny bit of the data in the live Kafka and put everything else on S3. And if that's seamless, it's wow, suddenly like it's so much cheaper and better. So I think that just like adding more use cases on top of the data lake is something that is really nascent. It's really like just starting, and I think there are a lot of new interesting things that can happen there.
And one thing as well that I see as being a big gap in the space is around being able to test and validate your ETL logic and being able to run it through a CI or CD pipeline to ensure that you're not injecting errors into your overall transformations, and being able to do a before and after comparison and ensure that the work that you're doing is what you anticipated and what you actually wanted given the real world data.
Yeah, no, I totally agree. I mean, I think that's probably one of our biggest focuses in our system is around previewing the data as much as possible and allowing you to very quickly iterate and be able to. I 100% agree with you there. I mean, especially because actually running an ETL process is very expensive. Like there's a huge cost associated with getting it wrong the first time.
Yeah, it's probably an entire episode on its own. So
Yeah.
With that, I'd like to thank the both of you for taking the time today to join me and discuss the work that you've been doing with Upsolver and trying to make the data lake a manageable and enjoyable experience. So I appreciate the work that you're doing on that front, and I hope you enjoy the rest of your day.
Thank you very much.
Too.
You too. And thanks for having us.
Listening. Don't forget to check out our other show, podcast.init, at pythonpodcast.com to learn about the Python language, its community, and the innovative ways it is being used. And visit the site at dataengineeringpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. If you've learned something or tried out a project from the show, then tell us about it. Email hosts at dataengineeringpodcast.com with your story. And to help other people find the show, please leave a review on iTunes and tell your friends and coworkers.